All right, it's time for general chemistry memorization 4 of 4. This is the most important one. This is significant figures. This will show up in virtually every question that you're asked because so many of the general chemistry questions revolve around numbers. This is how to work with numbers in terms of determining the correct accuracy and precision. So let's begin. Let's say you're taking a measurement. Let's say it's a liquid in a graduated cylinder. I see that this student has lined it up with the bottom of the meniscus as they should, and they're going to report a number. Now, should they say 32? Well, kinda. They definitely should say 32, but the general rule is to always estimate a digit between graduations. This seems to be right on the nose, so I think I would go with 32.0 mil, and the general rule is always estimate a digit between the graduations when that's what you're looking at, whether it be a balance or a velocity or whatever it is. That's what you do when you see graduations. Why did we bother to line up here? Why not go above or below? Well, they have a word for this sort of issue that develops. Clearly, if you're up here, you just can't see the bottom of the meniscus, for example. And so that's referred to as parallax. And a cute old-fashioned way that I can't resist showing was this mirror-based system that you really don't see much anymore, but it was really cool because if you're lined up to the side, you're going to get an inaccurate reading. Your eye will travel down and you'll get too low there. If you're over on this side, you will get a lineup that's too high. But you will see the reflection through a mirror unless you line up perfectly, and a device such as that will produce no reflection when you're perfectly aligned, and you minimize parallax. Some numbers are considered to be significant, others are not, and there's general rules. Let's go over them. By applying these rules, you will come up with a decent method for not giving excessive precision or way too little precision in a given measurement or calculation. So first we'll do the measurements, then we'll do the calculations, and we'll even cover combinations. So this can get a little tedious, but bear with me. 32, how many significant figures does that have? Well, 2, because you can't express it any other way. Non-zero numbers are always significant. Haha, this one I could say 3.23 times 10 to the minus 2, and that technically only has 3 significant figures, or just memorize the general rule, dump those leading zeros. Always. Here we got some sandwich zeros. We know that non-zeros always matter. We know that if they're to the left, we dump them. What about if they're in the middle? Well, we just have to say 3.004 times 10 to the 0 here. You can't get away from those central zeros. They're always significant. This has 4 sig figs. Then there's a cute little rule here that scientists came up with. If you don't have a decimal place, you're going to assume that they did not count these individually. They might have counted by hundreds or tens. So this will be assumed to be the worst case scenario without that decimal place. This has 1 significant figure, but if you do see it, and not a period at the end of a sentence, but if you do see that, we assume they were counting by ones, and that has 3 significant figures, all 3 of them. It wasn't 301, it was 300. This could have been 301, but because you don't have the decimal place. I hope you get that. So trailing zeros are significant only when you have a decimal place. Put it all together and tell me how many significant figures are in this number. I would go with 5 because we do have a decimal place. Can't dump the middle ones ever. Don't dump the final one because of the decimal place. Answer 5. I think, let's see, we might go here. How many significant figures here? Take a look, give me your answer. I would say 5, simply because we're going to dump the leading zeros always. We're going to keep the central ones always, keep the non-zero always, and the trailing one, in this case, we keep it because I do see that little decimal place, right? And so the answer is 5 significant figures there. Now, more importantly, what if you're dealing with these mathematically, which happens so often? Sometimes you will need to round. For example, let's just say you have the number 2.25, but you know you can only report this to two significant figures. The general rule is to round up. Some professors might have some weird system that they use, but this is a good general method. Always do what your professor says. So 2.3 works for there. If you're adding and subtracting, you're never better than your worst number, and that is to the level of decimal places. So adding and subtracting, keep the fewest number of decimal places. Unfortunately, we don't know what that next number is, so we really can't say 7.46, right? We are only accurate to the 10th. Looks like we got to round up, so 7.5. General rule, the significant figures for adding and subtracting is based on decimal places. For multiplying and dividing it, without going into their reasoning, they have a different rule, which is to keep the fewest number of significant figures. So this is clearly 2, but each one is accurate to 3 significant figures, so we're going to say 2.00. Infinite significant figures are the case if you're counting or if you have an exact relationship. You see 3 cows in a field, that has more than one significant figure. I mean, it's 3 cows, so that would be infinite sig figs. Similarly, 12 inches is exactly a foot, so if you're converting from inches to feet, you don't say, aha, I'm only going to report it to one significant figure. No, that is an exact relationship. Should you round as you go? The answer is never if you can avoid it. And if you can't, in other words, suppose you're doing some complex thing and you got to write down some number in between. The rule is you have to keep at least one what they call guard digit. That is to keep going. Most of you are pretty savvy with your calculators and you can just put it into the memory so you can round completely. This does mean that there's more than one acceptable answer. Since this is a rule to keep at least one guard digit, somebody might have 9. They may end up with a very slightly different answer than somebody else. Either one would be acceptable. How many should you carry along? At least one. Now, combinations. I love this topic because I believe if you did a search, you would find that it gets avoided. A lot of people don't do it. However, if you, more recently, there's some good YouTube videos out there that really, people have this nailed down. I used to just go crazy how textbooks didn't cover it. Check out the textbook that you give after you pay the, $300 for it and see what they do. And I think you'll find that they avoid it at all costs. But here's the general rule. If you have a combination, which you so often do, even when you just take an average, you have both multiplying and adding going on. What you do is take your intermediate data and determine how significant it is. Make a note of that, but always round at the ends. So let's use this one as an example. We have something in parentheses where we need to add and then multiply it by 33. So let's go ahead and add this and recognize that it's only going to be accurate to the 100th. We'll put a line under those significant digits, but carry along everything, and then we'll get an exact number and we'll round at the end. So when we do this one, apply as you go, but don't round is the general rule. And I did provide a link to a YouTube video from a woman who's teaching it. She is fierce, and sadly it's 8 minutes long, but I do encourage you to watch this because she's got it totally down. Her rules are great, and she even has little methods to do it that you might like. So let's take this number and add it up first because that's our PEMDAS rule. But recognize that it's only accurate to 3 significant figures when we apply that 100th rule for adding. It's only accurate to the 100th. So we have 3 sig figs there. We have 2 there. We'll report it to 2. So there's the exact number. Some people call it the raw number. We'll report that to 2 sig figs, which we could either say 270 without the decimal place or 2.7 times 10 to the 1. This is memorization of significant figures.